Okay, at this point, everyone should have their notebooks out and ready to take notes. This is 12.4. Solve logarithmic equations. Today's date is the 9th. Solve logarithmic equations. Okay, today's lesson is another big part of the test, and what we're going to be doing is using all the prior lessons to help us solve logarithmic equations. Okay, so here we go with number 1. Not sure if you've done this in Math 3. And if you did, they're definitely getting harder this year. Okay, log base 7 of x minus 1/2 log base 7 of 4 equals 1/2 log base 7 of 2x minus 3. Log base 7 of x minus 1/2 log base 7 of 4 equals 1/2 log base 7 of 2x minus 3. All right, just like when we had the lesson where we were solving, and I told you guys, let me show you really quick here, where I told you to get them to have the same base. Do you guys remember this lesson? I said get them to have the same base, and they had to be exactly one base on each side, and they had to be the same. Do you guys remember that? Same concept here. They need to have the same base, which they do. They're all log base 7. And same thing as the other one. There needs to be exactly one log on each side. Now, obviously, that's a problem here because there's 2 logs. So we're going to use our log laws to condense. This was yesterday's lesson. You had some homework problems where you were condensing. And that's what we're going to do here. And if you remember, when we condensed, we always brought these exponents up first, and we're going to do it on this side as well. So that will always be the first thing you do. If you have any coefficients, you bring the coefficients up as exponents. You're always going to bring your coefficients up first. Okay, so it's going to look like this. Log base 7 of x minus log base 7 of 4 to the 1/2, which we can simplify later, equals log base 7 of 2x minus 3 raised to the 1/2. All right, all I've done is I brought these, and I don't bring up a negative 1/2. I leave that minus, and I bring up simply the 1/2. I brought up the coefficients as the exponents. That's log law number 3. Okay. We want to condense this now, and it's a minus sign. If it's a minus sign, will I rewrite it with multiplication, or will I rewrite it with division? Correct. I rewrite it with division. And I'm going to go ahead and simplify this now. 4 to the 1/2 is 2. All right, so what was done? Brought these up as my exponents. 4 to the 1/2 is 2. Because it's subtraction, I rewrote it as division, and I condensed it to one log. Log base 7 of x over 2. And this just simply stayed the same. Log base 7 of 2x minus 3 to the 1/2. All right, now the 2 bases are the same, log base 7s. The 2 logs are the same, log base 7, and there's exactly 1 on each side. Once I get it to that point, I can drop the logs just like I did when I dropped the bases. So I'm left with that as my new equation. X over 2 equals 2x minus 3 to the 1/2. All right, so just like we did on a previous lesson, like what we did here, once we got them to the same base, we dropped the bases and we ended up with the exponents, 3x equals 5. And that's what we ended up solving. That's exactly what we're doing here. Get them to the same log bases, log base 7, drop the logs, and you're left with that as your new equation. All right, I'm hoping everyone recognizes that I cannot distribute the exponent, but I can raise both sides to a certain power to get rid of it. And what can I raise both sides to? The second power. Do you guys see that? 1/2. This is equivalent to the square root, so I square both sides, so the 1/2 and the square will undo each other. X squared over 4 equals 2x minus 3. This is definitely a more complicated problem, but at this point I'm hoping you guys know what to do from here. So if you've got it, continue, multiply both sides by 4 and solve. And I'm just going to go through one more time. Brought the exponent up, 1/2 and 1/2. Brought this as a fraction, x over 4 to the 1/2 is 2. Left this the same. Dropped the logs because they're exactly the same. Squared both sides because I wanted to get rid of that 1/2 power, and the 1/2 power and the squared undo each other. X squared over 4 equals 2x minus 3. So we multiply both sides by 4. Cross out. X squared equals 8x minus 12. And what do we do next? If I'm trying to solve for x and I have x squared equals 8x minus 12, I'm hoping everyone recognizes we're going to get everything to one side so we can factor and solve. Do you guys see that? I'm going to subtract the 8x, I'm going to add the 12 and get x squared minus 8x plus 12 equals 0. Why are we doing this? So we can factor and solve. And if we can't factor, then we use quadratic formula or any other method we have. Again, because it's an x squared, we get everything to one side, minus the 8x, add the 12, so that we can use the zero product property. And I can tell the two signs are going to be the same because it's positive 12, and they're both going to be negative, and I'm hoping everybody sees that it's negative 6 and negative 2. Set them equal to 0 and solve. X minus 6 equals 0, x minus 2 equals 0, x equals 6, and positive 2. Two solutions. All right. Yeah, I know that one was a complicated one, or a longer problem. Number 2. 1/2 ln x equals 3 ln 5 minus ln x. All right. We haven't talked about ln yet, but I told you guys it would come up. ln is the same as log. All the same log laws apply, all the same rules apply. Everything is the same. The only thing is ln is log base e. So whenever you see ln of x, that's equivalent to log base e of x. All right? It's just another way. We don't, when there's no base, we say it's base 10. So when it's base e, we call it ln, the natural log. We'll discuss more about that another day. All right, so same rules apply. I'm going to bring this up. ln of x to the 1/2 power. Bring that up. ln of 5 to the 3rd power. And there's no coefficient there, so minus ln of x. Now remember what was said earlier with you want to condense them to single logs, one log on each side. This side already has one. We're going to condense this one to a single log. And when I condense, multiplication, or a fraction since it's a minus sign here? Correct, it will be a fraction because it's a subtraction sign. If it was an addition sign, then I would have multiplication. 5 cubed is 125 over x. All right, do we have it down to 1 log on each side, and the 2 logs have the same base? They're both log base e, and there's 1 on each side, so I can drop the logs, and I have x to the 1/2 equals 125 over x. X to the 1/2 equals 125 over x. Now, there's different ways of approaching this, and if I was in class with you, I'd be asking about this time, what would you guys do next? But I'm going to go ahead and do it, and hopefully if you guys had other ideas, you can share them when I come back. I would multiply both sides by x to get it out of the denominator. And don't forget there's a power of 1 here that I do not see. And because these are like bases, what do I do with the exponents? Add them. Because I'm multiplying like bases, I'm going to add the exponents. 1 plus 1/2 is 1.5, which is the same as 3/2. I'll repeat that. 1 plus 1/2 is 1.5, which is 3/2. All right, and then I raise both sides to the reciprocal power. What's the reciprocal of 3/2? 2/3. Cross out, exponents undo each other. X equals the cube root of 125 squared. And that is something you can simplify. Cube root of 125 squared. Do the cube root first. Cube root of 125 is 5. And then you have the squared. X equals 25 is your final answer. Okay, I'm going to move on to number 3. Log base 5 of the absolute value of x minus 3 log base 5 of 3 equals 0. All right. Different ways of working this out, but what I see is I have 2 logs on this side and no logs on that side, and there's a minus sign right here, so I can simply just add this over to put 1 log on each side, which is what I'm going to do. All right, so I'm going to add it over. That gives me log base 5 absolute value of x equals, and I'm going to bring this up at the same time, log base 5 of 3 to the 3rd. Do you guys see that? Because it is a coefficient, and I said at the beginning of notes, we always bring that up to the exponent first. Log base 5, absolute value of x, equals log base 5 of 27. All right, one log on each side. They both are log base 5, so I can drop the logs. Absolute value of x equals 27. The absolute value of what number is 27? Positive 27 and negative 27. I don't know if you remember that from middle school, Math 1. Absolute value is plus or minus, because the absolute value of 27 is 27, as well as the absolute value of negative 27 is also positive 27. Absolute value. Remember, absolute value is the distance from 0. So the distance between 0 and 27 is 27, and the distance from 0 to negative 27 is still 27. Positive 27 and negative 27. And yes, you can write plus or minus if you'd like. Number 4. Log base 3 of x equals 4. Now this one is different. Do you see that there's only one log on one side, and there is no log on the other side? Here, I had no log on the other side, but I was able to move this one over and make it look like what we were used to. Here, there is no log on the other side. When that happens, you have multiple choices. You could convert this to a log. It takes a little more thinking, but it can be done. The easiest thing to do is change to exponential form. When you have only one log on one side and a constant or a number on the other side, change it to exponential form. Remember, we did that yesterday. It's where you do this. It's already an equation. The ones we did yesterday, we made an equation. It wasn't equal to anything, and we put equal x. Well, this one already has an equals 4, so it's 3 to the 4th power equals x. And what is 3 to the 4th power? 81. And hopefully that makes sense. If I gave you log base 3 of 81 equals 4, that would be true. 3 to the 4th equals 81. 3 to the 4th equals 81. All right, number 5. Log base 7 of 1 over x squared equals 2. Okay, is this more like number 4 or more like number 3? Correct, it's more like number 4 because there's only one log on one side and no logs at all on the other side, or no logs to move over. So we're going to change to exponential form. 7 to what power? Correct, 7 squared equals 1 over x squared. 49 over 1 equals 1 over x squared. You didn't have to make this over 1. You could multiply both sides by x squared. Some of you think of cross multiplying. However you think about it, you get 49x squared equals 1. Whether you cross multiply or multiply both sides by x squared and get it out of the denominator, 49x squared equals 1. Divide both sides by 49. X squared equals 1 over 49. And how do we solve this? correct. We square root both sides. Now don't forget, when you square root both sides, it's plus or minus. X equals plus or minus 1 over 7. X equals plus or minus 1/7. Okay, number 6. Okay, multiple ways of doing this. I need 1 log on each side. Now typically I would condense this, but I cannot condense because this is not a log. Do you guys see that? Typically I would condense these two together to make them 1 log, but I can't do that because this is not a log. Now if you wanted to, you could change that to log of 10, because these two are base 10 and log base 10 of 10 is 1. So you could do that. I don't do it that way. You can. What I do is I move the logs to one side, so then it looks like numbers 4 and 5. Okay, these are not like terms. I'm hoping you see that. This is log of x minus log of root x equals 1. Log of x minus log of root x equals 1. Now I can condense this to a single log because it's subtraction. And they're both logs. Where this was addition, but only one was a log and one was not. Okay, so this one I can condense because there's 2 logs and they're the same base. Log of x over square root of x equals 1. All right, now do you see it looks a lot like numbers 4 and 5? You're going to wrap around. What's the base that we don't see here? That's a base 10. So 10 to what power? The first equals x over the square root of x. Equals. Now it's up to you and how you want to do this. There's again multiple ways. I'm just going to do it this way. That's a 1. So I have x to the first power over x to the 1/2 power. X to the first power over x to the 1/2 power. Do you guys see how that works? 10 equals x to the first over x to the 1/2. And what do we do with the exponents when we're dividing like bases? Correct, we subtract. And what is 1 over 1? Take away 1/2. I don't even need to write that as 1 over 1. What is 1 whole? Take away 1/2. Half, so this equals x to the 1/2. Which if you've got it from there, you can finish. I'm going to repeat what I did. I put the log over to this side. So I could condense these two to a single log, and I did it with division because it's subtraction. Wrapped around 10 to the first equals this x over root x. And I changed it to x over x to the 1/2 so that I could subtract the exponents because the bases are the same. 1 take away 1/2 is a half. And then what do we do to both sides to solve for x? We square, and it's not plus or minus because we only do plus or minus when we square root. And I'm not square rooting, I'm squaring x equals 100. Okay, number 7. Log base 2 of log base 3 of x equals 2. All right, I know it looks wonky, it looks funny, but guess what? It is on the test. Okay, so we look at this and we're thinking, how in the heck do what do I do here? It doesn't look like anything I've seen. Okay, would you say this looks more like 4 and 5? Or more like 3? And it's kind of hard because there's 2 logs, but there's no plus or minus in between the 2 logs, not even a multiplication. This is not multiplication. This is log base 2 of log base 3 of x. Okay, this is not log base 2 times log base 3 of x. That's not how this is read. Log base 2 of log base 3 of x. All right, now, as weird and wonky as it looks, we're going to treat it like we did the last 3 problems, and we're going to wrap around. Why do we do that? Because there's no log on the other side. If there's only a log on one side and not the other, you're going to wrap around. So 2 to what power? The second equals what? 2 to the second equals log base 3 of x. 2 to the second is 4. Now I'm still trying to solve for x. Now I'm going to end up doing the same exact thing I did up here, but going the other way. 3 raised to what power equals what? 3 raised to what power equals what? 3 raised to the 4th equals x, and 3 to the 4th is 3 times 3 times 3 times 3. Therefore, x is 81. And if you actually checked it and plugged it back in, log base 2 of log base 3 and x is 81. And let's see if it works. I can't evaluate this until I evaluate this first. Log base 3 of 81 is asking 3 raised to what power is 81? 3 raised to what power is 81? Anybody know what that is? Correct, it's 4. Log base 2 of 4. This is saying 2 to what power equals 4. And 2 to what power is 4? It is 2, and that's what is on the other side. So it truly does work. It looks a little wonky, but it is possible, and it's a definite on the test. Okay, these last 2 are problems that are right off of your homework, and I'm picking to do them because they're on the test as well, and kids tend to struggle. So let's write it down. Log base 2 of 8 to the x over log base 2 of 1/4 equals 1/2. Okay, first off, I want everyone to recognize right now the difference between a log divided by a log versus the log of a fraction. It's the log of a fraction that we use to rewrite with subtraction signs. Okay, this is log law number 2. Log of a over b, or log of m over n, whatever it may be, equals log of m minus log of n. This is a type that we either break up or condense. Log of a fraction. This is not log of a fraction. This is a fraction with logs. Log over a log. So I cannot do any subtracting or anything like that. But what I can do is multiply this to the other side. Log base 2 of 1/4, log base 2 of 1/4. And why would I do that? To get it out of the denominator. Log base 2 of 8 to the x equals 1/2 log base 2 of 1/4. Now, think about what kind of problem this is. Is this one where we are going to wrap around, or where we're going to drop the logs? Because you have to understand the difference. When do we wrap around? We wrap around when there's one log on one side and a constant on the other. When do we drop the log? When there's a log on each side. One log on each side. One log on each side, we're going to drop the logs, but I'm hoping everybody is saying, wait a minute, we have to do something first. And what do we have to do first? Correct. Bring up the coefficient to my exponent. Log base 2 of 8 to the x equals log base 2 of 1/4 raised to the 1/2. Log base 2 of 8 to the x equals log base 2 of 4 to the 1/2 is the same as the square root, 1/4 to the 1/2 is the same as the square root of 1/4. And what is the square root of 1/4? 1/2. Do you guys see that? I brought the 1/2 up as an exponent. Remember, a power of 1/2 is the same as the square root. So the square root of 1/4 is 1/2. One log on each side. They're exactly the same log base 2. I can drop and drop. 8 to the x equals 1/2. And this is what we did like first day, I think it was Friday of last week. We get them to the same base. 8 is 2 to the 3rd raised to the x. And 1/2 is 2 to what power? Good. 2 to the negative first. So 2 to the 3x equals 2 to the negative 1. And once you get them down to the same base and exactly one base on each side, you can drop them and the exponents are equal. So you divide and x equals negative 1/3. All right, number 9, another homework question, another test question. 5ln of e over the 5th root of 2 equals 1 minus ln of x. Okay, there's a lot going on here. What kind of problem is it? Can you see, first off, let's see if I have the one. It's a lot like this one here. Can you guys see that? Where I got the log to the other side so that I could then do the wraparound. Do you guys remember that one? It was number 6. I got the log to the other side. It equaled 1. And then I did 10 to the 1st power after I condensed. Same exact thing I'm going to do here. I'm going to leave that one there, and I'm going to add the ln of x to the other side. Okay. Gone. And then I have, and I'm also going to bring this up at the same time. So what I have is ln of e over the 5th root of 2, all of this raised to the 5th power, plus ln of x equals 1. So what did I do? I brought the 5 up to a power, because we always do that first. So e over the 5th root of 2 raised to the 5th power. I added the ln x, so it's plus ln of x equals 1. In order to do the wraparound, which I'm going to eventually do, I need to get these to be the same, just a single ln or single log, which I can do because there's a plus sign, so I can condense using multiplication. Do you guys see that? Because it's addition, we're going to condense using log law number 1, which allows us to condense using multiplication. I'm also going to simplify this. E to the 5th and the 5th root of 2 to the 5th. ln of e to the 5th over, what's the 5th root of 2 to the 5th? 5th root of 2 to the 5th. It is just 2 because the 5th root and the 5th power undo each other. Another test one. I'll put a star here because kids tend to struggle with this one on test day. All right, so what did I do? Brought the ln over, plus ln x, and I brought the 5th power up, e to the 5th, 5th root of 2 to the 5th, which is just 2, condensed it with multiplication, and now what's the base here that I do not see? It's not 10. It is e. Why? Because it is ln. So when I rewrite it, what is it going to look like? E to the first power equals e to the 5th over 2 times x. Tricky. There's a lot going on in this problem, so I'm hoping you take the time to look back at it later on. I'm trying to solve for x, so what would I multiply both sides by to get x by itself? You could multiply and then divide, but I'm hoping everyone can see you can do it in one shot by multiplying by the reciprocal. Remember, e to the 5th is just a constant. It isn't, not a constant, it's a number. It's a decimal in your calculator that you can plug in. We're not going to, but we can. E to the 5th is gone, e to the 5th is gone, 2 is gone, and 2 is gone. And that leaves me with, I'm going to put x on this side. X equals e to the, forgot to show my work on this other side. My apologies. So times e to the 5th over 2. And I'm going to fix that for all of you who are saying, well, what did she just do? What I did was I didn't pay attention. All right. 2 over e to the 5th. Okay? 2 over e to the 5th. Why? Because that's a reciprocal of e to the 5th over 2. The 2 reduces, the e to the 5th reduces. What do I do over here? This is 2e to the 1st over e to the 5th. Can I simplify that? 2e to the 1st, because 2 times e is 2e. E to the 5th times 1 is e to the 5th. These right here are like bases, so what can I do with their exponents? Subtract. So x equals 2 to the 1 minus 5 is negative, and I don't want to write my answer like this, so how do I write it? What happens to the e to the 4th? It moves to the denominator. Or you can just say, hey, when I subtract, 5 minus 1 is 4, and there's more at the bottom, so it stays at the bottom, which is how I do it, but if you do it this way, that's perfectly fine as well. I know that was a lot to take in, but review it, study it, try it. When you do this one on your homework, it's exactly the same. Try doing it without looking at the notes and only use the notes if you get stuck. But make sure you go over it because it is one that kids tend to struggle with come test day. All right, we're going to put this aside and start our next lesson.